Awesome. Good afternoon, everyone. Welcome to Ask the Experts Windows Runtime. My name is Martin Lovell, and I'm the dev manager on the Windows Runtime team, which seems like a good choice for this afternoon. And with me, I have 5 of the smartest, most knowledgeable experts from across the Windows organization who helped us build the Windows Runtime during Windows 8. And we are going to start by introducing the panel. Thank goodness I have slides for this event. Without the slide, I would not have remembered to introduce the panel, so it's an important part of the exercise. And so let's start from left to right and start with Jerry introducing himself.
My name is Jerry Dunetz. I'm a partner development lead in the developer experience group at Microsoft working on the Windows Runtime. And my focus was on the consistency and usability of the Windows Runtime APIs, as well as in some of the base types that the rest of the runtime is built upon.
I'm Chris Guzak, developer, work on the Windows user experience team. My history is in client software, storage management, and application integration with Windows. Go back to Windows 95 and even Windows 3. And I work with these guys.
You helped invent the tree, the shell namespace.
I
iShell item is your baby.
It is. Thank you. Anyway, in Windows 8, I worked with these guys. It was a real pleasure to work on the Windows Runtime and bring some of those ideas into APIs that hopefully you guys are all enjoying using.
So my name is Elliot Omiya. People call me Eho. And I'm a developer in Martin's Runtime Experience team. And I built or designed a lot of the low-level activation, namespace, events, async delegates. So a lot of the violence in the predator and pattern, you can blame me.
Excellent. It's always good to know who to blame. My name is Chris Anderson. I was a dev on WinJS in Windows 8, and now I run the XAML in WinJS as well as the accessibility team. And so I have a bunch of history in the WPF space and the graphic stacks and things like that. So I've been working on the client technology for quite a long time.
My name is Carmen. I'm a dev manager on the Windows 8 app model team. During Windows 8, we developed the deployment stack, and we worked on the app container and some of the underpinnings of the HTML5 applications. I'm excited to be here and have an opportunity to answer your questions.
And finally, my name is Martin Lovell. I've been at Microsoft for about 15, 16 years, working on various kinds of developer technology, from the Visual Studio IDE, source control, debugging, C++ CLI, and most recently on the Windows platform. And among with all these guys, we managed to create a new developer platform for Windows 8, which was an extremely exciting, extremely nail-biting, and extremely satisfying experience. So I'm happy to here to answer your questions, and I think we have enough space to answer questions. So maybe now people who could ask questions can put their hands up. This session is being recorded, so we are going to wait for the microphone before we take a question. And you have to raise your hand to ask a question. OK, there's one down here, one over there.
She's going to run all around here. It's going to be awesome.
Thank you. So it will be a very basic question just to understand. Does a desktop application using on Windows 8, using WPF and WinForm, rely on the WinRT implementation of the CLR, or rely on the full Win32 implementations?
Should I take that one?
Sure.
So there is, in Windows 8, only one implementation of the CLR. There's one set of DLLs. And a desktop application built using the WPF framework and WinForms, which is what you asked about, is relying on the same CLR DLLs that have the code for the WinRT in it, but it isn't going down the WinRT code paths. And so that application is running just as it did in Windows 7, modulo any features or bug fixes the CLR team added in the interim time. Next.
Thanks. I know this has been asked 1,000 times, but I just know that I'm still doing something the wrong way. And that is that I'm checking, this app has to check hundreds of times if a file exists. And so I'm getting hundreds of exceptions. And I'm just wondering what I can do differently. Some people suggest, you get the list of all the files of the directory and you do string matches. Or is there a way to, without exception throwing, determine if a file exists?
Who wants it?
Chris, I
can
think
take
that's
it.
yours.
Yeah. So no. Short answer to your question. It's unfortunate. There are some, depending, so I assume the issue you have is in the debugger, you're seeing lots of exceptions flow by, and it disturbs your debugging experience. So you can disable exceptions in the debugger so you don't see them. So that might help you. You probably already knew that. So this is something that we've identified as, well, it impacts some people, and it's not desirable. We would prefer you be able to do this more directly. We are considering that, a change in our API. We didn't make that change because by the time we were considering it, it was getting late. We may address that in the future, but it's how it is today. So,
I have one additional comment. You could write a C++ WinRT object that called the API using WL and returned an H result, and then return that, and then suppress that H result beforehand, and so avoid the exception mechanics going on. So there's no difference really. An H result at the ABI level is the same as an exception at the next level up, so it's the same thing. But if you suppress the H result before it gets to C# or C++ CX, then you could avoid seeing the exception mechanism happening, and so maybe that would make your life a little bit easier.
I'm just wondering if one of you guys can take me through what the versioning story is around WinRT, and in terms of the release cycle. So do you plan to release with each version of the operating system, or will we see it in service packs? And really what that means in terms of running apps side by side with new versions of the framework as well, because line of business apps obviously have a longer term time to turn these things around. So.
I'll take it. OK. So we don't have anything to say about the future versions of Windows. And so right now, the versioning story for the Windows runtime is that there is Windows 8, and it has a Windows runtime in it. And I can guarantee there's a Windows runtime in every version of Windows 8, and beyond that, we have not announced anything. And so that's obviously a really good question, and we will obviously have something to share about that in future, assuming there's a future version of Windows, which seems like a good bet. But at this point, we don't have anything more to share. Sorry.
In the same lines as the file question, is there a way to, on the Windows 8 side, to understand if a file is open on the desktop side? So that, say, Paint has my JPEG open, how would I know that in my store app?
I can take that. So we attempt to open the file. It'll fail because the sharing, well, depends on how Paint opens the file, of course. It can open it with liberal sharing modes, and if you open it for read, that might succeed, or would succeed if it allowed that. I'm not familiar actually with what sharing mode Paint uses, but certainly applications can open files in exclusive mode, and that means nobody else can open it. So your attempt to open would fail in that case. So that's how you detect if it was open. Your attempt to open would fail.
Can I add one thing to that? The underlying file system is exactly the same between desktops and desktop apps and WinRT apps. So exactly, the conflict resolution will be exactly the same mechanism as if you are opening it from two desktop apps. There is no change here. The locking semantics applies.
Yeah, I have something to add here. So when we define the API, file API for new apps, we recognize this issue of sharing modes is very complicated, and apps can interfere with each other. And we chose this model that we call polite readers. And we built the file API such that when you open the file for read, you open it in a polite way regarding the sharing options. So you don't have direct control of the several different sharing options that the low-level file system provides. But readers are polite. That is, they allow other concurrent readers, and writers are exclusive. So they ensure that others don't change the file out from under them when they didn't expect it. So.
Hello. So I think, like everybody, I was very pleasantly surprised with the async and await capabilities. So thank you. And I think having this in the RT is quite impressive.
Oh, yeah.
Now, I wonder if you could share a little bit more technical beyond that. How many threads, how many tasks, how many can run concurrently, so that we just understand the limits of using the awaits.
Yeah.
So I can take that. So in terms of threading, typically the threads that will matter to the overall performance of your app are the background thread that an async operation creates. So like some of our file APIs are async or other things. And so they will create a background thread on your behalf and then do the work and then send back a completion at that point. One of the subtleties in this setup, especially with things like await or the PPL task in C++, is it will capture the calling context. So if you start from a UI thread on your main immersive window and then you issue that await, and then a background thread starts executing that, and one of the rules we have on implementing async operations in Windows is that when that async operations thread is done, it just fires on the delegate that it received as the completion handler. And so in many cases, it would cause a significant problem because this is some background thread that's running, and it's going to invoke your handler on a thread that you don't expect. And so kind of the magic of our doing the ABI or the application binary interface at the Windows level and then having really tight integration with the projections is that they capture that initial context. Where did I start that call from? And then they make that call. And when they do that, they arrange using an internal public mechanism, that I can discuss if it's relevant, to get that back to the UI thread. So in most cases, you will issue that async operation. The UI thread will continue to be able to service paints and input and whatever other things are happening on that thread. And then when that async operation completes, when you use the projections, it will get it back onto that originating thread. So in most cases, the system works kind of magically and automatically. And so that's kind of how it works when you issue an await or interact with async on one of ours. And if it's relevant, I can talk about creating async operations of your own. So I guess maybe I'll ask if I answered your question.
Yeah, and how many threads are used underneath that?
Okay, so the question is how many threads are used. And so the answer to that question is at least one extra one. So the whole point of doing the async is that we want to get the work off of the UI thread so we don't have spinning donuts kinds of apps that you've seen in the past. But it's actually up to the async operation itself how they perform that work. But typically it's one.
It's implementation detail as to how many. And to get an efficient implementation, we use things like thread pools, and right. There are issues if there's lots of these concurrent operations running, so we don't want to overwhelm the system with threads, so there's some throttling. But these are all implementation details, which mostly we don't want you have to consider.
There's one issue that I think is worth discussing at kind of a very high level, which is it's quite possible, since when you start an async operation, call await or use .then in JavaScript, to issue many async operations and then wait for them to come back. Well, the good news is that you can create many of these at once, and it's very efficient, and we can get all of these going. The bad news is they will all come back, I guarantee it. And the problem is you can get a large flood of work coming back onto your UI thread, and if you've ever built a really complicated website or web page, you have become familiar with the need to create too much work and interfere with the responsiveness and the operation of that web page. Well, the same thing happens in a XAML app in C# or a WWA app in JavaScript. Is you have to be careful about how much async work you create that will come back later, because if it all comes back at once, it can create a lot of performance problems. So be judicious on the rate at which you issue these and try to batch up and do those sorts of things.
I would add one more thing. I don't know what type of application you are considering writing or you're writing, but we have seen plenty of instances where taking this to the extreme can lead to severe performance problems. It's always a good idea. It's a pattern, one of those patterns that depending on what you do exactly and what async operations you call, the answer will vary. So like with everything performance, probably the only universally valid rule is take it slow and measure as you go. But the word of caution here is that we have seen apps that did not do that. They just went all the way without considering the performance implications. And when you look at the resulting experience, it wasn't good, and some of them had to do redesigns, partial redesigns, in order to alleviate these performance problems.
Next.
Hi. Why do we need yet another new string type?
Why do we need another string type? Jared, do you want to take that?
Well,
This is a great question. I asked Jerry this question.
Yeah.
Why do we need
Jerry.
why do we need another string type? So one of the fundamental goals of the Windows runtime is to sort of to project naturally into multiple very different languages. And so, well, we recognized that we couldn't just pick one of those languages string types given the nature of the runtime support. We need another. And so in terms of existing ones that we had, I guess, I don't know if you have a particular favorite in mind. Maybe I should target the particular favorite you might have.
How about Beaster?
But
Yeah, I'd go for com B-string because
Yeah,
it was
well,
crappy
okay.
in every language.
so one of the
And that was the problem.
And actually, so there are a couple of key reasons. So our string thing has two features. One is that it behaves as a value type, and so in general, and there's an exception to this, but I'll say in general, duplicating the string is not a fresh allocation. And so from a performance perspective, one problem with COM-B strings is that anytime you have one as an out parameter, someone had to allocate a fresh copy that's exactly the same as the previous string. And the adding up of the cost, both of the allocation in terms of performance and in terms of working set memory size, can be significant. So we didn't like that aspect of B-string. The other aspect is, and this is what leads to the slight exception to what I just said, is we also didn't want to force the allocation of a string for the simplest case where you have some programming surface that's going to take a string, going to use it for a moment, and be done with it. And so we created a model, which I don't know if everyone's familiar at the ABI level, where there are two ways to create an H string, the underlying type of our strings. There's a call called create string reference. And in that case, no allocation actually takes place when that H string is initialized. Now, if someone subsequently needs to hold on to it longer, they need to duplicate a reference, in that case, the duplication will do the allocation. So we're combining the possibility of a fast no allocation path for the simplest interactions, but the ability to share the strings without duplicating both in working set and in perf time every time that an out parameter is needed. So those are sort of the goals that led to the design that you're looking at.
So I had one short thing to add to that. I think we only created one new string that you care about, which is platform string in C++. JavaScript, you use the string you always had. C#, you use the system.string you always had. So that was really the goal, is that you would always use the string that you had. And since we created a new kind of C++ and it's used what we call C++ CX, that got a new platform string, which most closely mirrors what an H string was. But the goal was actually system.string looked the same in C# when we were done.
And when you pass the system.string to the Windows runtime, no copy is made, which turns out to matter significantly.
Hello. I have an application that's already published in the marketplace, and this application is supposed to run on RT ANA x86. Now I get my shiny Surface. I want to try my application. It crashes. It does not run, and it passed certification. What gives? Can we expect our applications to run x86 and RT when we publish, and also opted in for the both?
I can take that. Okay. We have seen a number of instances where application during certification doesn't behave exactly the same way on your machine. And this is not a new phenomenon. Depending on the nature of the problems, without understanding the nature of the problem, it's very hard to issue any strong guidance or advice on how to avoid that. But the thing to keep in mind is that the certification process is not an exhaustive test of any application by any stretch of the imagination. They do a set of checks, and depending on timing, we have seen issues where timing can be different, and during certification it can pass, and later on customers can have bad experience with this application. We have seen issues where the state is different. So, for example, they go through some initialization sequence during onboarding of the application, and it turns out that during that initialization sequence it works, but when you try different things, customers try different things in the field, again, it crashes. So the certification is not any exhaustive test of the quality of the application. It is much more about making sure that the basics are covered, and you can definitely arrive at a situation where you can produce a crash and certification says it's okay.
It's not just crashing on some instance. It will not load on any RT device.
It will fail to load on any RT device?
Yes.
I would love to follow up on that. This is the first instance I'm seeing where it's completely failing to load. We have seen crashes where it doesn't reproduce.
So one common case is if you have a development environment set up and you have the debug version of a component in your package, that will load for you on your development machine, but on the retail machines it won't. So
no, they should be resigning that. They should be.
Okay, this is through.
Come grab us afterwards, and we'll give you a business card. And
I would love to hook up with you after the talk and understand a little bit more. It should not be the case that it just refuses to load plain.
Great.
Can you please explain the decision not to allow Windows RT to domain join? Was it a technical issue or perhaps a product differentiation issue?
I don't think we have any of the right people in the room to answer that question. Like, that's not a Windows runtime issue, and so that's probably not a question we should answer here.
Hi, can one query detailed hardware, system, and battery life information from RT, from a store app?
I'm sorry, I didn't catch that.
Can you get the detailed hardware information?
Oh, can a store app get hardware information about
battery life
about
information?
A device?
Yeah, that type of thing.
Carmen, do you know the answer to that?
Detailed hardware information, certainly not. I'm not 100% sure about battery.
I think we don't do battery. We don't report battery.
As a user, you can go and run, there's a Power CFG tool that will give you a really detailed battery report that outputs this giant HTML file. But I don't think that's programmatically accessible.
Not that I'm aware. May I ask what's behind the question?
Actually, before that, so we generally have a philosophy that tries to keep applications out of the business of inventing and evaluating policy, where the system should really be responsible, or maybe the user. So in general, we've avoided exposing lots of details about things like how much battery you have, because we don't want your application to behave differently as a function of that result. So,
and I'd say, and one of the fears there is that we've seen a history of applications sort of making decisions for themselves that don't really make sense when 10 different applications try to make the same decision, whether they're using the same algorithm or a different algorithm, the same policy or a different policy. And so we like to build the policy into our services so that we don't have the chaos that results from each application making its own different decisions.
Just as an example, the background transfer API, it is sensitive to network state in terms of cost versus no cost and things like that. And we don't want the applications to consider it, although they can, and that there is a way to test that. But we want the services the system provides to abstract and encapsulate the behavior.
Yeah, the reason behind this isn't to use that information to change the behavior of the application. It's simply to report to the user in our application.
The UI of the system, when you swipe from the side, the battery information is right there. So I'm not saying that necessarily it'd be a bad idea in your design, but pointing out that information is available for users in a pretty visible way already.
One of the things we have tried to do is make sure that the users always have a consistent experience, which is in the benefit of, actually turns out, all applications themselves, because users get familiar with the device and they feel confident navigating it, especially when it gets to less technical users. And we have tried to stick to the principle that the same information can be retrieved from the same places. And probably, as Chris pointed out, maybe the users will be happy in your case to just swipe from the right and see the better information there.
Yeah, specifically my usage case is creating a benchmark and to be able to get, to verify, the results. That's the reason from a programmatic standpoint. But that's a corner case, I guess.
Yeah.
Our app needs to deal with very large files which can be split into multiple parts. The user opens the first part of it, and then we have to get to the rest of the parts. If these things happen to reside in the documents folder, we're fine because we have the capability for that. But if it's anywhere else, we can only open the first part because we don't have permission for any of the other parts. Is there any resolution for that?
In the Windows 8 app model, we don't allow access to arbitrary parts of the file system. This is done with the intent of protecting the confidence of the user. Again, it will be interesting to understand a little bit more the details of the scenario. However, I would say that generally there are certain types of system management, system configuration applications that you cannot write a Windows 8 store app for. The platform, as it exists in Windows 8, is not well suited for this type of application. So there is definitely a point where you're going to hit a brick wall where, well, I'm trying to read these files or change these files, and the system wouldn't let you. But maybe we can, again, talk after the talk or get more information about your scenario if there is something else we can do to meet the needs of your scenario without giving permissions to the broader file system.
Hi.
Hi.
Do you plan to support more languages which are projected by the Windows runtime? This is the first question. And the second one is a JavaScript HTML model also coming to Windows Phone in the future, so to the Windows Phone runtime?
Those sound like questions about the future.
Yes.
I have been led to believe that there is a future coming and that it will have additional days, weeks, and months, and maybe even software. But unfortunately, here today, we're to talk about the present, not the future. Sorry.
I have a two-part question as well. One relates to the device question. I would like to be able to retrieve the device information because we would like to use that information for tracking purposes to know what hardware we need to provide the most support for. My second question is there, because there are different Windows 8 versioning, is there any way to get the specific Windows 8 version information?
That's probably for me. So we don't offer APIs for retrieving the hardware information. The way we expect that you guys will be able to consume this information in a very handy way is in the developer portal. You should be able to find information about how your app is being used, and if there are things that are missing there, it may be good for us to understand what gaps exist. What was the second question? The second part of the question?
The second part is there are several Windows 8 versions. Is there any way to get the specific Windows 8 version for your device, the device you're currently running on?
Do you mean like RT versus just Windows 8, those versions? Yeah, I'm not familiar with a way to distinguish.
Well, so there's one version only shipped one version of Windows 8. Processor difference, I don't think we expose that, but of course you can go run some code that could determine that. Or your code, if you have some native code, you're compiling it in one way or the other, so you could build a component yourself that reported.
But I don't think we exposed the SKU.
Yeah, there's no version, because there's only one version so far.
There's only on the app side, the platform is exactly the same. So from your app shouldn't have to do gymnastics to run differently in a different version of the platform. If the motivation is market intelligence, probably the developer portal is the best place to retrieve this information. We're trying to make it real easy for you to obtain the relevant information for how your app is being used there, so you don't have to build all of these components that people had to build in the past to understand how the application is being used.
Regarding protocol handlers, are there any concerns with regards to more than one app handling the same protocol, particularly if those apps can actually do two different things?
I can answer that too. The logic that we have in the system, first of all, I should explain the principle. We have started with the principle that for Windows 8, we want the user to be in control of the situation. We have received plenty of complaints before Windows 8, and I have experienced some of those myself, and I'm sure you have experienced some of those frustrations as well, where you install a piece of software, and it suddenly turns out that some of your file type associations or protocol associations have been hijacked, and when you click on your favorite file type, something else happens that you didn't intend for it to happen. So the way we did it for Windows 8 is whenever there is a new candidate to handle your protocol file type, the user will get a little pop-up which says, hey, now you have more choices here. Which app do you want to handle this particular protocol or file type association? The user chooses, we remember that preference, and we're going to honor that until there is a change in configuration. Obviously, the user has also a UX, which is, however, is more advanced, where they can go and change this preference. But there is no programmatic way for apps to query, override, or anything like that. The user makes the final choice. That's the principle we stuck by.
So to your question, though, so URI protocols should have a specification that describes their basic form. So your question about multiple applications using the same URI protocol, URI scheme, those applications should agree based on that specification how those URIs should be handled at a basic level. So if the URI scheme is well specified, there should be no issues.
Yeah, I think in a perfect world that would be the case. But for example, Bing Maps has their own protocol, and there's nothing.
They have a specification for how it works.
Right, but there's nothing stopping me as a developer to kind of look at their protocol and handle it differently. And you would say that okay, you're conflicting with the quote unquote the spec, but the system nevertheless will accept that. And if you have Bing Maps and some other app that implements that same protocol, even if you set one as the default, I could have hijacked that protocol, and then the next time that protocol is used, it will call my app as opposed to Bing apps.
You cannot hijack a protocol. The user is always in control. You can put in your manifest a request to handle this protocol, and will pop up the UI to the user, and then the user will make a choice. And if the user likes what this other application does better than what it likes Bing Maps, that was their choice.
Yeah, I consider it the same as a file format. If people don't interpret the file format the same way, bad things happen. We hope people interpret file formats the same way.
Hi, I'm interested in the projection creation process and how that kind of happens behind the scenes. Like I've heard of WinRT kind of being like COM on steroids, with the new inspectable interface. But basically, it's a COM interface, and it goes like I assume there's some enhanced IDL process that takes place during compilation, and then it goes to, I guess you go to different projection layers. If we wanted to say replicate that projection process from WinRT into say a new language of our own, can you kind of just briefly describe kind of how that process works internally, if it's an okay question to ask?
Sure. Well, there are different kinds of languages with different kinds of approach to projecting WinRT types. At one end of the spectrum, you have JavaScript, which at runtime reads the Windows metadata from the Windows metadata directory and uses that to construct internal JavaScript type objects that represent the parts of the WinRT namespace and enables JavaScript calls to call them. And that happens all at runtime dynamically. And as Windows changes, if a Windows service pack introduces a new API, JavaScript will just see that automatically. At the other end of the spectrum, there's C++, where the metadata is read entirely at compile time, and used by the compiler to construct some classes and functions and so on that are available to you in your source code and referred to that way. And so in both cases, the commonality between those two things is the Windows metadata. And what a projection does, essentially, is read the metadata at some time that suits the style of language, either at compile time if it's a very static language, or at runtime if it's a very dynamic language, or if you're kind of a hybrid of the two, like the CLR-based languages are, you read it both at compile time and at runtime. And then it uses that to construct objects that are effectively thin, efficient wrappers around the WinRT functions themselves. And an effective projection is making those wrappers as thin and as lightweight as possible while matching the user's type system. You want that projection in the CLR world. We use system string to represent a string, and then that automatically and very rapidly gets converted down to an H string at the projection level. So that's how the metadata fits into the language's world.
Okay, that makes perfect sense. And then just one follow-up quick question on the iInspectable. Is there caching, call site caching that's taking place at the internals of WinRT, or would that be something we would do if we wanted to, say, reflect against the WinMD for developing those wrappers on the fly, say, with JavaScript? Is that happening underneath the hood, or is that something we would want to implement ourselves?
I don't think I understand what you mean by call site caching in this context.
I apologize. Let's say that you reflect against a type. JavaScript reflects against a type, and it builds, it invokes that type. Then let's say it goes to call that same method again. Is that that process of interpreting the WinMD, so forth, is that kind of cached behind the scenes now?
So the WinMD reading APIs that we provide do a certain amount of caching of the metadata.
Right, that's what I mean.
The actual objects you create with Activate Instance and get back as an iInspectable and use, it's your job in general to decide to keep that iInspector around or keep the class factory around and repeatedly use it over and over again. In general, WinRT doesn't cache any of that stuff for you,
No.
Except to the extent that Windows is caching pages and making things faster the second time you do them in general.
Okay, makes sense. Thanks.
In the specific case of JavaScript, you'll want to cache your namespace and variable references just because it does dynamically walk the dots. And so it is important for you to cache that just because if you get into tight loops, that can actually add up to cost.
I think anybody who's written systems and APIs and things like that has run into the case of you put it together, you put it out to customers to use, and then they use it in completely different ways than what you had expected it to be used, right? And so I was wondering if you had any observations of really unusual things that you had never expected it to be used for, and it was, and sort of the subsequent of that is if you discovered gaps in what you had created that you, at this point, since you can't talk about the future, at least regretted not having put them in at some point in the past.
So what are our regrets?
Does anyone have any particularly unusual uses they've seen a store app put to? Carmen, you have any particularly weird store apps you've heard of?
There is an almost endless strings of. You guys know how this works. You put your software out there, and it turns out that people use it not the way you intended it, and sometimes that's great. That's creative. You admire that. Sometimes you think, well, people are trying to get themselves into trouble. This is never going to work. I would say that probably the biggest thing we're seeing right now that people don't think enough about when they pull data from the web, including from random places, that they don't often think enough that this data could be authored by anybody. And they need to be careful with data that comes from the web, that they don't end up compromising their app from a security standpoint or the user data that they have access to. I think the issue of the throwing exceptions to figure out whether a file exists has been raised, so we're not going to go over that again. Any other comments, guys?
The one that I think that at least some of us were surprised by is there's a number of shared components that end up getting written in C# and then get used by JavaScript. And so we ended up with these weird scenarios where we'd spin up multiple GCs and all this stuff. And so we kind of look back at that and go, well, we really should have had better guidance about using C++ for shared components that are going to be consumed by arbitrary customers, as opposed to if you know the customer, like you're building some LOB thing and you know that everyone's going to use C# or VB on top of you. It's awesome to write WinRT components in managed, but I think that some of these shared system things would have been better to write in C++.
Yeah, just to add to what Chris was saying is, we're seeing definitely instances where people get themselves in trouble from a performance standpoint when they have JavaScript applications. They try to do something heavy in C# behind that, and if you haven't experienced that, grab your Surface, try those apps, and you'll understand what we're talking about.
Next, I don't know who was next.
Oh, right, Mike's right here.
So just a quick question. On the projection layer, and when you pass memory into WinRT, is that memory then pinned if it's like a managed language? Do you have to pin that memory so that it can't be moved around by the CLR?
So if you pass memory in,
so if you're passing pointers
using the CLR,
so I'm
it
just
is
saying
going to do the right level of pinning for you. So CLR will appropriately pin the things you pass in to WinRT.
So in a XAML app, I would have to just keep aware that that memory is going to be static until it's released from the WinRT.
The number of times memory actually gets passed in rather than an object is pretty small.
Okay.
So in general, what's getting passed into the WinRT is objects or value types that are being copied. If you pass in memory block, the CLR is going to leave you in a safe place. But it's actually a pretty uncommon case in the universe of the WinRT projection.
And I would say, for the most part, you shouldn't have to worry about it.
Yeah.
I mean,
it's barely going to impact you.
There's questions.
I'm losing. I don't know who's next.
This guy had his hand up.
I have a few questions. One question about crypto. It seems that WinRT cryptography is significantly reduced compared with what we had in copy or CNG. For example, there are some low-level encryption algorithms. There is a way to request certificate, but there doesn't seem to be a way to work with certificate or certificate storage, even when specifying that shared certificate access is desired. There doesn't seem to be any classes that would allow to do this. Is that something that intentionally cut off from the code, and we should no longer rely on it and just forget about it and go OpenSSL route? Or what should we do? And the other question is closely related to it. Is there any plans for FIPS certification of this crypto?
Okay. The second question is about the future, and so I'll decline that one. But Carmen, do you know about the crypto situation at all?
So I'd say there's no principle that says we wouldn't extend that API set. There are definitely some things you do with certificates that store applications shouldn't be able to do, but there isn't a principle that says that API set shouldn't be extended. And if there's need for it, it's the kind of thing we would extend.
And we'd love to hear from you about the scenarios that are missing that we maybe.
I will say that none of us happen to be on the team that is most responsible for that, but we would love the feedback and make sure it gets passed to the right groups.
And to answer kind of the implicit question, what we did with the APIs was very deliberate. Many of us here spent a long time looking at exactly which APIs came in, exactly what they came in, and exactly what they were to support. And so while we don't have the crypto guys here to answer in detail why, we can promise you it wasn't an accident, but there was a very deliberate process that came around to the exact list of APIs we have.
One more question. It's probably closer to the question of unusual uses of the WinRT. I've noticed that when there were developers preview and consumer preview, it was possible for the file picker from inside the file picker extension to invoke file picker itself. But when released version of Windows came out, this operation stopped working. I am wondering if the initial ability was something that was introduced just by accident, or the fact that it got removed by accident. Was it deliberate?
I think it was deliberate. I don't remember exactly, but I suspect it was deliberate. Just I'd say design principle-wise, not API design, but UX experience-wise, we didn't want nesting of pickers.
Can you explain the thought process behind restricting WinRT apps to a single monitor on a multi-monitor setting?
I think there's principle-wise, there's we would like to be able to have.
Jensen told us that's how it's supposed to be. I think they think that's the principle.
Oh yeah, that's right. That's how it is today. The system we created is restricted to a single monitor. Principle-wise, I don't think that's there's nothing that says that's something we wouldn't want to extend in the future. but that's the future. So,
yeah.
I guess there's also a little bit of the sausage making thing on that. Is like thinking about multiple monitors is a pretty difficult problem, and so there's sort of the whole point about we needed to ship on time, and so some of these things are just reducing the number of things we were trying to support in the things so that you could get this sooner rather than later.
Yeah, hi. What mechanisms are available for communication between Windows Store apps and perhaps between a Windows Store app and a desktop app? At the moment, on the desktop, we use sockets to do that sort of thing.
We work hard to make that not work.
We have been very deliberate in opening only specific channels of communications for which the user is in control. We have been inundated with feedback from previous Windows releases where it all starts well, and by the second or third year, something called WinRot kicks in, and it turns out that for the average user, some percentage of machines had some functionality that stopped working, and we couldn't tell easily why is that or how is that. So for Windows 8, we started with a very deliberate choice that the only way apps communicate with each other is through protocols and file types associations, which is a mechanism that users clearly understand. The user is always in control, and there is no possibility of WinRot because, because we control the registration and the deregistration of these things for Windows Store apps. So by design, these are the only two mechanisms, and this is how we wanted the system to behave.
and of course, we have contracts, sharing and picking and things like that. So there's several rich app communication systems. They're very specific, though, and not general purpose by design.
Yeah, we're all mediated by the user.
Yeah, I mean, we're searching for a low-level private channel of communication between tightly related applications.
And our hope is that you don't find it.
Okay.
If you find it, let us know.
If I find it, I won't let you know.
Well, and more fundamentally, we'd like to challenge you to reimagine your applications a little bit. You know?
Right. I mean,
did I use a buzzword? I'm sorry.
You're certainly
when we went back to work out what apps we would build for Windows 8. We didn't just say, hey, let's take the apps we have and bring them to Windows 8. We said, well, what would be the right division of labor? How do these apps split up?
Yeah.
And we redivided the boundaries between them in some ways. And often the right answer to the question, how do I make two apps communicate, is you don't have the right number of apps. Maybe you should have one, and maybe you should have 5. But maybe the way you have it split up today isn't really the right way for the Windows 8 app model.
Well, that sort of leads me then on to my related question. You've perhaps neatly related that for me. Can a Windows Store app, a Windows 8 app, create UI on multiple threads? So rather than communicating between two different applications, I can have completely disparate UIs within one application. The scenario I've got is an application and a debugger, for example. That's the analogy. I want them to be, at the moment, they would be separate applications. If that's not possible, I want it to be an application which has the end user UI, and then the debugger or the monitoring UI is a separate part.
So I can take that question.
Great.
So one of the other things I did was designed and wrote part of the core application, which is kind of the first object that comes up in all your apps. And it's the thing that kind of enforces the UI threading and windowing model in Windows Store apps in Windows 8. And so basically the general model is the user invokes a contract, like clicking on a tile in the Modern Explorer. Excuse me, I'm not supposed to use that term. In the Windows Immersive Explorer. And basically that will come to life, and the core application object will create a thread, create a window, and then hand that to you. So that's how the first one comes up.
Yeah.
There is also on the core application a create new view object. And that will create a new window and a new thread, and then you have 2 of these full-size immersive windows available in your app, and then the core window object has an activated, and then you can use that to switch between those. So you can create 2 completely views that are independent on independent threads that can show individually. But if you want to show 2 views in the same one, you have to do UI work in one of those core windows.
Okay, but it sounds like then it's it's built in there to have two completely separate views.
Yeah, so core application, create new view.
Core application, create new view. Thank you.
Can I say something about debugging as well?
Yeah.
The APIs we brought into the Windows 8 SDK for store apps do not include all the APIs you need to write a debugger. And Visual Studio is still a desktop app, and in general, debug versions of things and debug tools we think of as not store apps because they don't have to ship through the store. And so one model that would make sense, if you're a debugger, you can go attach to a process, you can reprocess memory, you can do lots of debugger-specific things, and you don't need to think about your debugger as a store app. That would probably be the wrong way to model that. Certainly, if you think about how Visual Studio relates to a store app, it's not a store app relationship. It's very much a debugger-type relationship that doesn't come under a store app protocol.
Yeah. Yeah, that sort of makes sense. If I may throw another language out here, what the product that I'm talking about, we have an APL interpreter. So when we debug the code that's there, it's dynamic, it's interpreted. So when I talk about debugging there, I'm actually not talking about system-level debugging. Sure. I'm just talking about debugging through that.
Sure. Yeah. Then the two-view model might be good for you.
So, sounds perfect, yeah.
So you will have to build the user experience for switching between the windows within your app.
Yeah, sure.
The system switching considers all the complete set of windows in one app as one thing.
Right.
Yeah, but if that's all we need to do, then that separates things out nicely for us and gets us away from the app communication as well. Thank you.
Okay, who's next? We have about 10 minutes to go.
So we are trying to use the web view control in the XAML, WinRT XAML platform, and we have some serious issues with that, and memory issues, Z-order issues, input issues, performance issues, so all kind of issues. And
that sounds like a lot of issues.
Yeah. Yeah. And so I don't try to ask about the plans, but do you feel the pain we are experiencing with that control?
I feel your pain.
Thank you.
No, we're definitely experiencing a bunch of pain with the web view control. It's one of the things that we've definitely seen as a consistent thorn. A bunch of the ad components that people are using in their XAML apps make this even worse because they embed in the ad control. They think of it as a normal XAML control, and underneath covers, it's creating a web view underneath so it can host an HTML thing. So in that case, similar to that problem before we had of the C# component being loaded up into the JavaScript app, here you have a case where you have a nice XAML app and you end up loading an ad, and that ends up loading HTML, which ends up loading JavaScript, which ends up, it keeps going. So we absolutely feel your pain, and the future is the future.
Thank you. Great news.
Have you surfaced this on the social MSDN, some of these issues? Because that's a great way of getting visibility to us in some of these issues. We see a lot of issues. We get a lot of communication flow back to us, but it's always good to put it there because we read those things and watch it. And so that's how we know how to feel your pain, is you express your pain in those forums.
If you have issues, send us a list of your issues, preferably the software-related ones.
Mr. Cellini.
Thank you. So a follow-up to an earlier thread. Can a Windows Store app open a port and run a web server?
Can a Windows Store app run a web server?
I can take that. You can open certain ports. You have to have the right capabilities for your apps. No, you cannot open the web server port, not in any exclusive way. So you can obviously I think there are APIs for listening on HTTP, if I remember. Do we expose that in WinRT? Okay, so not sure if we expose the right APIs for that, but purely from a permissions perspective, you cannot exclusively open port 80.
And on a general thing, the Windows Store app will be suspended when the user's looking at something else in general. Probably not the world's best web server. So, there's that.
Agreed.
A lot of latency in that system.
It's kind of a special purpose.
But I think in the case of, let's pretend for a moment that you're building a multi-user game of some kind.
Sure.
And that you're going to do coordination between those. We do have the ability to open ports and communicate across those things.
Yes.
And so in the case of that sort of scenario, I think that's something that there's the right APIs are there.
Yes,
Yeah.
you can do that.
Yeah.
Who's next? There's a guy down here.
He's been waiting very patiently.
Yes.
Every time there's a break.
Hi. Why does the WinRT iInspectable interface iBuffer make me to do useful things with it? I have to use oldcom. I have to use iUnknown to query interface for iBuffer byte access. That seems a blast from the past, I think. Why was that done that way?
Well, first of all, I'll say we feel your pain. This is definitely a case for that answer. But
it's just how it is.
Well, it is how it is. But we know that many people have found it awkward. Let's put it that way. Basically, direct memory access isn't consistent with the sort of the type-safe approach of many of the languages that we have and the metadata system that we designed here. And so we needed a bridge between the efficiency of the direct memory access that you're looking for, that iBuffer byte access, I believe it's called, provides, and the metadata describable model that is fully remotable that the rest of WinRT is based upon. And so iBuffer is the solution to that problem. The need for something like iBuffer was particularly sort of amplified by the fact that our I/O model, for very good reasons, is fundamentally asynchronous. And so that means that, for example, in a read async call, you issue your read async call, that call returns. The implementation of read async has to have a place to put the results safely. The set of requirements basically led to the design that we have. And as you say, if you're programming as a C++ programmer, at a certain point you want to drop into the iBuffer world or the iBuffer byte access world to get the most efficient access to your data. Do you want to add something, Chris?
Well, it's just the garbage collected languages. This is incompatible with their design. So either you go down to the low level using a low level tool, or you stay at a high level, have safety, but you might suffer performance-wise.
So is there a way for me to write an app that can be like a Bluetooth keyboard to be used by some other device? There's that kind of access into the Bluetooth controllers and stuff.
Can you elaborate? How is the app on Bluetooth keyboard?
Well, say my app, you can type like a keyboard, it's sending it to a different device, so they can connect to my app as the keyboard. For, say you have a PlayStation and you want to be able to use your tablet to be the keyboard for that device.
Anybody know about Bluetooth APIs?
I don't think we have the experts on the
yeah.
Bluetooth APIs up here.
I have no idea.
Certainly you could have an app that has a keyboard that people type on, build the UI. I don't know if we provide the Bluetooth stuff to do the other part.
If you come afterwards, get a business card, we'll follow up and get you
follow
connected to the right person. I know exactly who to talk to. Anyone else? We have 2 minutes to go.
About performance scenario, before we started using async APIs, it was common, let's say, I need to process entire directory of files. I will process one file at a time, everything synchronous, so it is obviously slow. I would create my separate thread, and that's where it will be going. Now, when there are async API, when I start processing the entire directory, I basically issue lots and lots and lots and lots and lots and lots of async requests to these files, which might be going into the potentially overloading system. Is there any way to structure it better? Do you have any guidelines how to do what application should do in this case not to overload the system?
Yeah, this is a good topic. So there's a sample. So what language? C++?
C++.
Okay, so the PPL team provide you tools that let you do that. Use asynchronous pretty simply, built into the SDK, but they allow you to do things like that, spin up lots and lots of async operations. They have a sample that demonstrates a way to serialize those and basically use their system in a way that produces serial access, and you should try and find that sample, or I can maybe help you find that. And it's definitely something you want to do in that scenario.
Can I add one thing to that as well? Our async system makes it easy to build other async things. So one way, if you have an async operation that you want to reduce its impact on the UI thread, is to build a composite async task that sits on a separate thread, does a lot of subtasks for you, and then reports results once the UI thread when a larger lump of work has been done. And the technology we provide makes it easy to build your own async ops if you want to, although that is definitely an advanced activity.
I was not worried about a UI thread in this case because this request was already going on from the other thread. But I was worried about overloading system itself because I can now issue so many requests for the opening files so fast, and all operations take a while. So I can now issue 1,000. I want to open 1,000 files very fast. Where before each file would be opened serially and slowly only after one finishes operation and so on.
So I guess at a high level, I would encourage you not to do that.
His point is how,
yeah,
and there are techniques, and they are a little bit mysterious. They're in the sample, and they're not that well explored.
I mean, at a little bit less jokey way. I mean, batching up things into less granular work items is really going to benefit the performance of your app tremendously. So beyond that, creating algorithms where you kind of meter the work so you don't distribute it all at once can be a useful technique also.
And if you're building an app with visual elements, think about doing the work for the stuff that is actually on screen right now, and maybe the page of stuff that's one page down or above, and maybe only that stuff, and getting that stuff done first, before you go off groveling the other 10,000 things that are in that folder or whatever. Because a significant problem we saw with early Windows 8 apps was people kicking off one async item for every item in the whole view, and then hoping the initial view would draw quickly, which it obviously didn't.
Yeah, and that question was asked also earlier. I definitely second the caution there that, for example, if you're doing file reads, if you do byte at a time, and you're doing async operations, you're most likely to overwhelm the system. You can definitely push it too far. Batching, judicious batching, is generally the pattern that tends to work well in these cases.
And that's generally simpler than building, a kind of a semi-sophisticated scheduling algorithm.
Okay. It's the end of the talk. There are some resources on the screen. I'd like to thank Jerry, Chris, Iho, Chris, Carmen for coming along and helping you guys understand the Windows runtime. We will also be here afterwards and take a few informal questions in here or in the corridor. And I'll obviously have business cards if anyone wants to follow up by email. So thank you very much for coming.